I'm Anil Kumar sharing with you some review questions for composite functions. Here we have three different questions. I'll explain you how to solve these. Followed by these three, we'll have a test question which will look like this. So I'd like you to pause the video, copy these questions, try them out, and then look into my video. So let's see what the questions are. The first one here is, let f of x equals to 1 over x plus 12 and g of x equals to 2x squared plus 4. What are the domain range of f of x and g of x? Find f of g of 1, find f of g of 2, state domain of each composite function. Question number 2 is, let f of x equals to a straight line and g of x be a parabola. Graph them on the same set of axes. Describe the graph of f of g of x as a transformation of the graph of g of x, right? So we'll get a composite function and we have to describe as a transformation of a parabola. The last question here is, show that if f of x equals to 1 over x minus 2, then f of f inverse x equals to f inverse of fx, right? So you see, we will be discussing what the composite functions are and also with their inverse function. This test question here involves two functions. Both of them have restrictions in their domain, so that will be a good test question for you, and I hope you understand the concept by the end of this video. Now let's first talk about composite functions, then we will take a solution to all the three questions written here. So composite functions, basically, as you see this, we are talking about something like this: f of g, another function, right, x. It could also be written as f of, like this, right, function of g of x, and you know both f and g are functions of x. So these are the two ways in which we'll be normally writing the composite function, and basically it means if I write f of g of x, that means first we have to perform the inside operation. If I'm placing input-output machine, for example, then we are talking about two machines. The first one is performing the operation g of x, and then the next one is performing the outside operation. So I hope you get the concept. The idea is that if you provide an input, let's say x, then the output will be g of x, and then the output will be f of g of x. Let me rewrite this with values. Let us say if I provide x as an input, then this function here is the inside function g, and the output is g of x. Then g of x acts as an input to the function f, and the output is f of g of x. Perfect. So that is what our composite functions are like. So now you understand this concept. Let me also show it with an arrow diagram, right? At times you may prefer to show them with arrow diagrams. So let us say, let me take this space here. Let's say this is my input x, which is going to give me output g of x, which will give me, after the composition of these two functions, f of g of x, right? So it's kind of like this, that the function g performs on x. So this is the function g which performs on x, and it will give you g of x. Do you get an idea? And then from here, the output will become input of the next function. So we get an output here. The function f now performs on g, and the output we get is f of g of x, correct? So that is the diagram. It clearly shows one thing, that the domain of g becomes the ultimate domain, and then we have to look into the output of g of x if there are some elements which could be restricted because of f, then they add to the domain. You get an idea of domain from this diagram very clearly. Correct? So with this information, let's move forward and answer these questions one by one. The very first question here is f of x equals to 1 over x plus 2 and g of x is 2x squared plus 4. What are domain and range for these functions? I know it's not a part of this to sketch these functions. However, it becomes simpler if we make a small sketch here and then visualize all the solutions. So the first function here may look like it's a reciprocal of x plus 2, x plus 12. So there's a vertical asymptote at minus 12, correct? And the horizontal asymptote is the x-axis. Therefore, the function, if I write x equals to 0, you get 12. So that means the function is positive here, kind of like this. Is it okay? And symmetric about these asymptotes. So this is your function f of x. As far as g of x is concerned, is a parabola which opens up. If x is 0, it is 4, symmetric, even, right? So it's a function which is like this. And the points of interest could be this vertex, which is 4. And here we have this point as minus 12. Correct? Now that helps us to answer most of the questions very easily. The first one. What are domain and range of f of x and g of x? Let me use this space here for f of x. So for f of x, the domain is what? Clearly, domain is x belongs to real numbers. However, x is not equal to minus 12, right? So x is not equal to minus 12. As far as the range is concerned, range is all real numbers, but is not equal to 0. So y belongs to real numbers and y is not equal to 0. Clear, right? As far as g of x is concerned, what we notice here is that the domain is all real numbers. There is no restriction. As far as the range is concerned, it is greater than or equal to 4. Perfect. So we got part A. Now let's look into part B. Okay, let me just draw a line here. Now we'll understand how to evaluate these functions, right? So part B, first let us find what is f of g of 1. Now we have to always start from inside and then go outside, right? That is the whole concept. That is, we are saying f of g of 1. Now when I say g of 1, basically I mean I have to substitute 1 here in this equation, find the value. So if I substitute 1, I get 2 plus 4. So I get 2 plus 4. Do you see that? So I substitute this value of 1 here in this equation. 1 square is 1, 1 times 2 is 2, so we get 2 plus 4. And so I could write this as f of 6, right? Now I have to substitute 6 here. You get an idea? So if I substitute 6 here, I get what? I get 1 over 6 plus 12, and it is 1 over 18. So f of g of 1 is 1 over 18. Is that clear? You can actually pause the video and try the second one, which is very similar, right? So let's do the second one, which is okay, let me write g now here. G of f of 2. Okay. So that really means we want to find what f of 2 is. So we'll do g of f of 2. So I'll substitute 2 here this time. So I get 1 over 2 plus 12, right? Which is 1 over 14. And that gives me g of 1 over 14. And now I'll substitute this value there. So I get 2 times 1 over 14 whole square plus 4. Correct? So this is what you get. Now you can always calculate this. Let me use calculator at present. Well, it's not a recommended thing to use calculator, but let's do it. So it is 2 times within brackets 1 divided by 14 whole square, and then we'll add 4. Okay, so we get some big number here, which is 393 over 98. That's it. So you don't have to really use a calculator. I'm just using it. However, if it is restricted, it's not a difficult calculation. Anyway, let's look into state domain of each composite function. Okay, so I need a space for that part actually. So when we have to state domain of each composite function, which is f of g of x and g of f of x, one way is you can form the functions, right? The other way is you can look into and then answer. For example, if I am looking into f of g of x, the only restriction for the function f is that input cannot be minus 12, negative 12. What you notice here is g of x is always greater than 4, right? So we can write, since g of x is always greater than or equal to 4 with no restrictions, then what it really means that the output of g of x can never be minus 12, and therefore in this case we can say that the domain of f of g of x is x belongs to real numbers. Do you see that part? Correct? So even I have not even calculated what f of g of x is, but I'm able to say what the domain could be. Perfect? You could do like this. Okay? Now the second part here is to find domain for g of f of x. Now as an exercise, you could actually find these functions and then write the domain. Now as far as f of x is concerned, clearly it has a restriction in domain, and the restriction is minus 12. So for this function, I can say that the domain of g of f of x is what? Is x belongs to real numbers, where x is not equal to minus 12. The restrictions in f of x will remain the restrictions for this function. Perfect. You could of course write f of g of x as a function and figure it out, but that takes time in the test. But this is a good strategy. Anyway, we'll practice even how to write functions as composite functions in the next exercise. Okay, I hope that part is clear. So let's move forward. Now we have two functions, linear and parabola. There are no restrictions for both these functions, correct? So this is a very easy example. It says, let f of x equals to 2x minus 1 and g of x equals to x squared. Graph f of x and g of x on the same set of x's. Describe the graph of f of g of x as a transformation of the graph of y equals to g of x. You can take a good graph paper to sketch these graphs. I'll do a very rough sketch here just to explain you the concept. Okay, so let us say that f of x is a straight line, slope 2, y-intercept minus 1. So let me make a line like this, right? So this becomes f of x for me. Let me write here f of x. And to be very specific, this is minus 1. If I put y equals to 0, I'm expecting a value of half. So this will be half. Okay. Now, second one is g of x is a parabola, which is what this. So let me just draw a parabola. So we are not really bothered about the scale here. Okay. A parabola, which is, we are saying g of x. And a good point to write is this point, which will be 1, 1. Okay, 1, 1. Right, so this is your x-axis. Now, we have drawn all this. Describe the graph of f of g of x. Now, we have to draw graph of f of g of x. Now, last time I didn't do this. This time we are going to work it out. So that really means f of inside function is x squared. Correct? Now, what we will do here is that we'll replace in this function x with x squared. So we get 2x squared minus 1. Do you get an idea? So that becomes f of g of x. Let us sketch this function. We can write transformation from this function also. Perfect. So it's not a difficult thing at all. I hope the concept is clear to you. To sketch this function, f of g of x, let's take another ink. Okay. So if I write x equals to 0, I get minus 1. So this point is common. Is it okay? To get 0 here, I get 1 over 2 square root. So 1 over 2 square root. Okay. Which is approximately, so 1 divided by square root 2 is 0.7, right? So this is 0.5. So I should have drawn it because somewhere here it is going to cross. And if x is equals to 1, we are expecting a value 1. So there is a common point, right? So which is kind of, let me just draw this graph now. Okay. So I stretched it vertically by a factor of 2. And this point I found was common. This 1, 1 is common, right? So minus 1 will also be common. It doesn't look like, but anyway. So we have two invariant points here. Minus 1. Also, minus 1, 1 is also common. So that becomes the graph of f of g of x. So on your graph paper, if you get these common points, your graph is perfect. Now here, we have to describe the graph of f of g of x as a transformation of this. Perfect. So let's describe. So we are talking about now two graphs. One is f of g of x, and we are comparing it with g of x. The two graphs clearly are, we have 2x squared minus 1. This one is x squared. So the transformations are very clear. You can always write these. Vertical stretch by a factor of 2. The second one is vertical translation. 1 unit down. So you can clearly see that this transformation has been influenced by the function 2x minus 1, correct? So that function gives you the transformation. So whenever you're doing composite functions, remember that you could actually represent them as a kind of transformation of inside function by the outside function parameters. You get an idea, correct? So let's move on. I think that is a good concept to remember. Now the next question here is, we are given two functions which are f of x equals to 1 over x minus 2, and the other one is inverse of that function. So the question is, Show that if f of x is 1 over x minus 2, then f of f inverse x is equal to f inverse of fx. Okay, let's try to do this. So we are given the function f of x equals to 1 over x minus 2. Remember the restriction, x is not equal to 2. Perfect. Now to find the inverse, we'll flip right and then calculate. So let's find the inverse. So we could write this as x equals to 1 over y minus 2, and then we'll just cross multiply. Y minus 2 equals to 1 over x, and we say y equals to 1 over x plus 2. You could also write this as 1 plus 2x. Is it okay? Is the inverse of this function. So we got f inverse now. Now as soon as you get this f inverse, you know on the function x is not equal to 2. And what you also notice here is that y is not equal to 0. Correct? So when you find inverse, you can see that these conditions have flipped, right? So now what has happened is that x is not equal to 0 and y is not equal to 2. Since the horizontal asymptote on this function is 2. Do you see how these restrictions also flip when you're trying to find the inverse? Correct? Now these are very important restrictions to consider to prove that f of f inverse x and inverse f of f are same. Correct? So what we will do now is find what left side is and what right side is. So let's figure out what is f of f inverse of x. So that means we are trying to figure out what is f of, now inverse x, you could use either one of these equations, right? It doesn't really matter. So now I have to keep this function out. So I'll prefer to use that particular equation, right? So what I will do here is use this equation. It gives me ease because when I write a, because I have to replace x with this value. So when I flip this, and then write 2 and 2 will cancel. So you'll just see why I'm using this one. So f inverse could be written as 1 over x plus 2. Does make sense to you, right? So that becomes f inverse. So this is also equals to f inverse, right? So you could use either one of them. Okay. So now we need to substitute this in this function. So what we get here is 1 over. So instead of x, I have to write all this. So instead of x, I'm writing 1 over x plus 2, right? And I already have minus 2 there. Do you see that part? So plus 2 minus 2 is 0. So I get equals to 1 over x, which is x. So I get this function as x. Okay. Now let's do the second part, which is f inverse of f of x. So in this case, this is the outside function. We're not finding inverse, right? So okay, so that is the outside function. Call it g of x to avoid the confusion. Inside function now is 1 over x minus 2. Now we'll replace this inside function into our inverse function. You're getting an idea, right? So let's do that. Think this is g of x, okay? Don't find inverse of this, okay? Now I'll use this part of the equation because if I use kind of a fraction here, it's kind of easier, or either that is also okay. So we are doing one of these two. Okay. So still we'll replace x with all this. We'll replace x with all this. This is better. Anyway, so what we are going to do is we are replacing this function. Okay, so no need to write f inverse. Let me just cross this out. So what we have here is 1 over, instead of x, I'll write this. which is, let us say, 1 plus 2x over x minus 2. So I use this time this one. Now you can take common denominator and simplify. So if you take common denominator and simplify, you get 1 over 1 plus 2x minus 2x over x, and that gives you x again. So both these functions are actually equal to x. Now if you do like this, you may lose some marks. The idea is we had some restrictions here, correct? So that is what I want to highlight. Now we had these restrictions. That means x is not equal to 2 and y is not equal to 0. So these are restrictions which we have seen. So when we do this composite function, then we know two things, that x is not equal to 0. So whenever you had these two composite functions, you know x cannot be 0 here, right? So we know x is not equal to 0 because that part is not defined in that case. Is it okay? Now when you do this part, I mean when you calculate it further, then you find that x is not equal to 2 also, since whenever you get this equation here, you get x is not equal to 2, right? Now when you substitute this value here, x cannot be 0 because this is not equals to, that is not defined. Perfect. Now in this equation also you'll realize that when you solve it, we actually cancel it out anyway. So what you find here is that both are equal to x, but x has a restriction that x is not equal to 2 and is not equal to 0 because this is composition of these two. Perfect. So what we do right here is that f of f inverse x is equal to f inverse of fx. Is it okay? Okay, so we should write like this, which is equal to x where x is not equal to 0 and 2. So it's a straight line where there are two holes. One is at x equals to 0, the other one is at x equals to 2. Correct? It's very important to take care of that restriction. It is not just a straight line. It has restrictions as we had been talking about. Is it okay? Now, let's have your test question, which is right here. I'd like you to copy this question, answer, and then look into my suggestions. The question here is, let f of x equals to square root of x and g of x equals to square root of 4 minus x. What are domain range for these two functions? So let's write out the functions. First is f of x equals to square root of x, and we know the domain and range. Let's sketch it. Okay, we'll do the sketch here. The function sketch square root x, as you know, is kind of like this. You can clearly write down domain range, and the next function is minus x actually. So we need this side. So here we could write domain range. We know the domain here is x belongs to real numbers where x is greater than or equal to 0. Range is y belongs to real numbers where y is greater than or equal to 0. Now this function g of x, think like this. We could rewrite this as taking minus common, we get x minus 4. Now that is better. That means it has been reflected and then move 4 units to the right. Correct? So it's kind of like this. So clearly what we have here is that the domain is, in this case, domain is x belongs to real numbers, but x is less than or equal to 4. And the range is y belongs to real numbers and y is greater than or equal to 0. Do you see that? So this becomes domain range for your both the functions. Now it's important to have this kind of picture in your mind when you answer. What is f of g of x? Now you look for f of g of x. So g of x is the inside function, right? So you could say f of this, which is square root of 4 minus x. And then you have to replace this in your square root function. So what you get here is square root of, instead of x we write 4 minus x. Do you see the fourth root coming into picture? Correct? So that becomes your function. And in this particular function, 4 minus x, now you can clearly see that x has to be, that becomes the restriction, the inside function restriction. Is it okay? So in this particular case, the domain is that of g of x, which is that x has to be, so it is x belongs to real numbers where x is less than or equal to 4. Is it okay? So let me write this as curly brackets. So that becomes the domain for this particular function. Is it okay? Now let's do the next part, which is g of f of x, g of f of x. So that means g of square root of x, and that means we'll just substitute this here. So we get 4 minus square root of x. Now, both have restrictions. Now what really happens here is that the square root function is positive, and if that is more than 4, then the outside function will fail. Perfect. So here we have more restrictions. Do you see that? So that's the composition of these two. You can very clearly see that as soon as this output goes beyond 4, we have a problem. So to find the domain, what we have to say is that 4 minus square root of x has to be greater than or equal to 0. Correct? Or we say 4 is, we take it to this, is greater than or equal to square root of x. And so when we square, that means x is within plus minus 16. When you square, it is absolute value of x, correct? So you have to be within this. So that becomes the domain. Do you see that part? So that's very interesting to figure out. So that is kind of critical for this particular question, right? So understand how we got this. That's your problem, okay? So basically you need to understand that square root of x squared is actually absolute value of x. So it is that absolute value of x is less than or equal to 16, and therefore you get this. Is it okay now? Perfect, perfect. Okay, anyway. So the last part here is f of f of x, correct? So that means f of square root of x, and that means square root of x. Is it okay? Or fourth root of x. That becomes your function. Now, fourth root of x, x has to be, so the domain here is that x has to be greater than or equal to 0, where x belongs to real numbers. Is that okay? So that is how you can actually answer this question. So with that, I hope you have understood all the concepts of composite functions. And it's kind of very important to look into their domain and range, as the domain of a composite function is influenced by domain of inside function and then the output of the inside function. Perfect. So that is important to understand, which you have seen here, how it is being influenced if both have restrictions. Feel free to write your suggestions and comments. If you like and subscribe, that'll be great. Thank you and all the best.